Today we're going to look at entropy and the second law of thermodynamics. Previously we've looked at enthalpy, which was one type of thermodynamic function. Entropy is actually the second one, and there's a third one we'll look at later, which is called free energy. Okay, so what we're looking at is we're looking at whether something is referred to as thermodynamically favorable. So we need to talk about that for just a second. The idea behind thermodynamics is that we can predict ahead of time whether a chemical reaction is worth investing in, whether it's worth producing that product, or if it's just never going to happen, or if it's going to happen, how much energy will it take to get that reaction to happen, or if it does happen, how much energy can we get out of this. So from an energy standpoint, this is very important because if we're looking at replacing fossil fuels at some point in the future, thermodynamics is going to help us figure out whether those processes are worth doing. So I'll get more into that as we go along, but first of all, what does it mean for something to be thermodynamically favorable? What it means is that a process will happen on its own without us doing anything, okay, other than getting those components together, or maybe getting the reaction kind of started in a way. Examples of that would be like an iron nail will turn to rust. If you think about it, if you put an iron nail outside in the elements, it will spontaneously, on its own, or thermodynamically favorably rust on its own. The idea is that we just have to put the iron nail into the elements and it will do this process. Now, in the textbook, they use this word spontaneous. The AP test is substituting it with what's known as thermodynamically favorable. They didn't like the word spontaneous because it was misleading to students, and I understand it, but the problem here is that your textbook uses spontaneous. I still use it in my vocabulary. I will try to change to thermodynamically favorable, but when I'm talking about spontaneous, I am talking about things being thermodynamically favorable. What that means is, from a thermodynamics point of view, the rusting of nails, of iron nails, is favorable. Now, if you think about it, if you put a pile of rust out into the backyard, into the elements, into the the weather, that rust is never ever going to convert back into a nail. That is not thermodynamically favorable. So certain things seem to have only one direction in which they go, and they don't go back in the other direction. Gases will spontaneously float a container. So if I have a gas, okay, and I put it inside a small container of gas and I open up the lid and I let the gas out, it will spontaneously fill up this room, right? It always does that. It's never going to be have a lid open and all these gas particles go back into the container. That's not going to happen. Heat always spontaneously flows from hot objects to cold objects. So if you put a pot of water on a stove and turn the burner on, the water will always get hotter. You will never have ice cubes form in that pot of water. So as we said, certain things seem to go in one particular direction. They seem to be thermodynamically favorable. So we want to find a way to predict this thermodynamic favorability. Okay, and the first thing we need to do is make sure that we understand what thermodynamics does and what thermodynamics doesn't do, because there's a little confusion here. So first of all, what it doesn't do, okay, does not consider the pathway. Only we look at our initial and final states. So that's what we call a state function, or we talk about state functions. So it doesn't matter how it gets to the particular point that it's at. All we care about is what was it initially, what was it finally. Okay, it gives information. It does not give information on time or speed. Right? That's all kinetics. So just because something is thermodynamically favorable doesn't mean that it's going to happen right away. So you got to keep that in mind, that we're separating out kinetics from thermodynamics. Okay, what does it do for us? It's going to predict whether a process is spontaneous or thermodynamically favorable. Right? It's going to tell us which direction a reaction is going to go. It's also going to give us information on a particular why a particular process occurs. Okay, we'll get to that a little bit later. And it also is going to tell us the direction at which it will occur. Now, hopefully you remember. Hold on. Direction. That should remind you and bring up things like equilibrium and K and Q and all that stuff. So we're going to go back and review some of that in this chapter. It's why I like doing thermodynamics at this point. We can go back and review some stuff for equilibrium.